Great. Boil, condense, freeze, melt. Okay? So homogeneous, you need to use phase changes, like a box of gas or a box of liquids you would heat up or cool down. Okay? So I want to just, in our notes, write down or get this copied down, the picture of distillation. Where is it? All right? It doesn't have to be perfect, like, you know, like a super artistic drawing. But I just want you to have it down so you really have a good image of what distillation is. Mind hitting the lights, Liz? Please. All right. So copy this down. This is distillation. Again, what is distillation? You were supposed to look it up. Oh, I forgot. We'll check that in a little bit. This is what it looks like. But distillation is when you use differences in boiling points, right? So if you have, let's say, tap water here, and you heat it up, the water will evaporate and boil, but the minerals, the solid junk in water, that's not going to boil. So that will be left behind in the flask. So the water evaporates, condenses, this is a condensing tube, drips into this. This is called distillate. This is pure H2O, right? So if this is tap water, right? This is tap water. This is going to be distilled water. That's pure H2O. Just H2O. Nothing else should be in that flask. What's left over here, you're going to have all this sediment down the bottom here. That's not going to evaporate. So just sketch that, all right? Good. Don't spend like 10 minutes drawing this. Take like a couple minutes, all right? This here, water in, water out, is tap water that's going to be circulating around this inside. This inner tube here has the water vapor. The big fat tube here has the tap water coming in and going out. That's condensing the hot vapor faster. You can just let it naturally condense. It would take forever. All right, again, that's distillation. That's how you separate homogeneous mixtures. Distillation's another one. All right, so once you're done with that, you know what? Actually, I'm going to show you another way to see. This just occurred to me. For AP Chem, I have good pictures of chromatography somewhere here. I know I do. Where would you be? Where are you? Where are you? I have it somewhere. Ah, here it is. There we go. Okay, so the next image is going to be how chromatography works. You don't have to copy the next picture down, but we are going to write chromatography in our notes. So I don't know if you have room under homogeneous, right? So we had homogeneous on the left, heterogeneous on the right, and then we were writing underneath it how to separate it. So if you can add chromatography, that's another way to separate. This is under homogeneous. Can I get rid of this picture? Are we good? For the most part, again, it doesn't have to be like, you know, good enough for the Louvre or something like that. Okay, so chromatography, here's an example, all right, and what is it? It's how to separate components of a mixture, and usually that's homogeneous, okay, like ink. Okay, so for example, ink, and the way it works is the water, I would rather just explain it than write on and on and on, but the way it works is this paper, just like I have up here, is put in some sort of solvent, all right, and then you put, like, the ink spots are here and here, right? So there's your ink spots. The solvent, maybe it's alcohol, maybe it's water, maybe it's something else, okay? But whatever this solvent is must dissolve the ink, otherwise this won't work. So the water, let's say, is going to absorb through the pores of the paper because of capillary action. You raise your hand if you've heard that before, capillary action. Your biology learned about it. Cohesion, adhesion. One second, I thought you needed help for a second. Okay. So cohesion, adhesion, what that means is water is attracted to itself and to the paper. So as one water molecule climbs up the paper, it's attracted to the water below it, so it pulls it up, okay? It's almost like people climbing a mountain when they're all linked together, okay? One goes up, they pull the rest with them. That's kind of how water works, going up paper or trees, for example, plants. So water climbs up. It dissolves the ink as it passes through the ink, and then these are the different components in the ink, separated dyes, just like here, okay? So we have different components here. We can show Skylar, there's the different colors in black ink. All right, so the only thing that's it. We're done with like Regents level stuff, but advanced or AP concepts. This dye is more attracted to the paper than that dye. This dye is more attracted to the water. Because if the water is going up, as the water moves up and up and up, if the component in here is more attracted to the water, it stays in the water longer. If it's more attracted to the paper, it comes out on the paper first. So down here at the bottom, this yellowish color, that's more attracted to the paper. The bluish color at the top is more attracted to the water because it stays in the water longer. That's a more advanced concept that has to do with bonding, and it's a little confusing. We don't need to really get into it in Regents, but that's how chromatography works. Okay, so that's that. Okay. Next, I was going to show you an image, but I'll just show you this. This is another way to separate a compound. I'm going to put water in here. Okay, or this is another separation technique. Sorry, but not for mixtures. I know we're talking about mixtures. This is how we separate a compound. So I forgot to mention this the other day when we talked about compounds, which is fine. But if you want to separate compounds, you have to do it how? Physically or chemically? Physically or chemically? Chemically, right? So we're talking mixtures. This is physical stuff, okay? But I just got the part I needed here for this, so I figured I'd show you. So maybe tomorrow, Friday, or whatever next, I'll show you eventually. This is how you separate water. So there it is, Skylar. So you put water in here, and you're going to plug this up, and you're going to hook wires to these two things here. I don't know if you guys can all see. All right, and then this is hooked up to a power source on the lab tables. So you're going to send electricity in here through the water, because tap water conducts electricity. I'll explain more when I do it. But anyways, what happens is the water splits. So you get hydrogen gas on one side, oxygen gas on the other. And then to prove it, you can open these up and light them on fire, because oxygen and hydrogen are flammable. So the gas accumulates in here, you open these up, the gas comes out, and you light it on fire. It's kind of cool. So you can separate water, but you need electricity, right? So it's a good example of how to separate compounds. Separating mixtures is, I think, easier to show, and it makes more sense, right? Boiling, evaporating, chromatography, I can show you these things pretty easily. This is harder. Electrolysis, you need electricity to separate the compound chemically. So it's just to show the difference between a chemical change versus this is physical, okay? Just dissolving, all right? So again, I will show you that eventually. So we will write that word down, electrolysis, but not right now because I don't want to confuse you with the mixture talk here. All right, let's see. Just want to make sure I'm doing everything I needed to do. Went over the bookwork, went over that, chromatography, distillation, we showed that. Okay, so yeah, we're done with elements, compounds, and mixtures. I guess, you know what, why not? Let's just write that word down here, a little star, electrolysis. Put this underneath your notes on mixtures. This is not for mixtures, it's for compounds. I know it's a little bit out of order, I apologize. It's good that you hear the word though. Electrolysis, oop, what did I do there? Wrote it twice. Electrolysis. Okay, electrolysis is separating a compound with electricity. And again, we're going to put in parentheses here, that's a chemical process. So for example, write this down in your notes, H2O, arrow, put ELEC, meaning electricity. So water is our reactant. If you send electricity through the water, you will get hydrogen gas and oxygen gas. Those are your products. So reactants on the left, the yields arrow, products on the right. Bless you.
Whoever that was. Who was that?
Okay, so that was kind of the last thing I want to talk about with elements, compounds, mixtures as far as separating and just reviewing that with you. So what do you need to know for this stuff? Substances, elements, compounds. How are they different? How are they similar? How to separate a compound. This is really the one method that you'll ever be asked about. Mixtures, how are they same? How are they different? Right? Homogeneous, heterogeneous. How to separate them. Chromatography, distillation, filtering, stuff like that. All right? Okay. So that's it for elements, compounds, and mixtures. All right. Raise your hand if you looked up those definitions. Be honest with me, it's easier that way. You two forgot. All right. Okay. So now what we're going to do in our notes here, we're going to define those two terms. All right. Ooh, I only have 2 minutes? What? All right. Good. You can put your notes away. Okay, so I have this little packet here. I'm going to bend this little silver metal coin. Okay? Something's going to happen. But first, you know what, we'll do it tomorrow, but first feel it. Go ahead, just feel that thing. Go ahead. Just in your mind, I want you to say, is it hot or is it cold? Is it room temperature? What do you think? Okay, first thing tomorrow, we're going to bend that little coin and we'll see how it changes, okay? Is it hot? Is it cold? Is it room temperature? Hot, cold, room temperature. What do you guys think? Room temperature? Anyone think it's hot? Anyone think it's cold? Coldish. Room temp, right? Of course you think it's cold. Cold. Okay, cold room temp. Tomorrow, we'll see what happens. No homework.